Okay, this is problem 4b, and in this problem it's asking about the differences in the growth rates and in the crystallinity, and talking about explaining these differences based on, I'm presuming based on the structure of the polymers. So again, this question is about polypropylene and polystyrene. And I'm just going to clear the board here. And these, as you know, the different structures of these is that the polystyrene has a mer structure like this, involves benzene ring here. And this is the repeating unit, and I'm omitting the hydrogen atoms for simplicity. This is the repeating unit structure in the polystyrene, and in the polypropylene the structure is the same. This is not to scale, with a methane pendant group here. So what we know is that this one has a maximum crystallinity of 63% crystallinity, and over here the crystallinity maxes out at 32%, and we also see difference in the growth rate. The growth rate here is 20 microns per minute, and whereas we have the growth rate over here of 0.3 microns per minute. Okay, so we have slow growth rate on this side, slow growth rate, low crystallinity, and here's the structure. Here we have high crystallinity, high growth rate, and this is the structure. Now it turns out that both of these are synthesized through the chain growth mechanism. And so, as you know, the chain growth mechanism consists of 3 steps. It consists of initiation, propagation, and termination. So these 3 steps are all a series of chemical reactions, and if we had to examine why are these growth rates different, it's something about the difference in the way in which these take place. Now, termination, this is just the end of the growth process. If I had to guess, I would guess that the difference in growth rate is this step here, propagation. And the propagation is essentially assembling each of these chains together, and what that requires is that you break the double bond that is usually here in order to add these chains together. Initiation just is the initial breaking of that bond with some sort of reactive agent, and that proceeds usually quite rapidly. But in the case of these two, you can see that this just has a much larger pendant group, making the breaking of this bond and then the reacting of it just sort of sterically more difficult than in this case here. So that is why this, I would say, the propagation of the growing of this particular polymer would be much slower than the propagation of this polymer.